Okay, so today we're going to talk about functions. And, basically a function is kind of a block of code or instructions that is designed to do some kind of specific task. Okay, and I'm just going to kind of give a brief overview of how functions work in Python. Okay, just a very general, kind of an easy introduction, and kind of give you an idea of how to construct one and how they can be used. So I'm going to build a function that calculates the average of a set of values. Okay, so a set of numerical values, and we want to calculate the average. And the average is defined as, summing the numbers up and dividing by how many you have. So I'm going to start over here, and the way it works is you start with this reserved word called def, which kind of defines the block. Okay, and then we're going to give it a name. So we'll call it mean value. Okay, so you want to be a little bit creative here. And then I'm actually going to pass it a parameter called values. So values in this case will be numerical. And again, this is a word I made up. It's not a reserved word. And then that kind of defines the function, the name, and that we're going to pass something into it. And then we have the core of it here. So first thing we're going to do is take the length of those values. So if I pass in 10 numbers, take the length. Okay, len is a Python word command, and we'll get 10 because that's the length of our data set if we're using 10. And then we're going to calculate the average, which is simply summing those values, dividing by the length, and we can return that number. Okay, so that is a basic function on how to calculate an average of a set of numbers. So let's see how this works. So let's go ahead and take this, copy it, and we'll go over here. We'll start Python up. Okay, so go ahead and paste it in here. So these little ellipses mean that it's a continuation. Hit enter, enter again, and our function is now inside the computer. Okay, and we can see it. It is a function, and it is indeed a class function. So let's see how this works. So I made up a set of numbers over here, a list here. I'm going to copy that, go back over to the terminal. Okay, put those in there. So we've got our values defined as x. And now we're going to call our function. So we're going to say mean value of x, and that gives us the average of those numbers. So it's taken that list, it's run it through its internal logic there, and it's kind of given us back a number. Okay, it's given back us the average. So let's try one more. Okay, let's do the median. So the average is pretty straightforward. Now I'll do a little lesson statistics here. The median is basically taking a set of numbers, sorting them, okay, from highest to lowest or lowest to highest. And then if the list is got an even number of elements, okay, the median will be the average of the center two. And if it's an odd number of values, the median will simply be the middle one. Okay. So first thing we do is we define a name for it, called a median value. We're going to pass it some values here. We're going to take again the length of those values because we're going to have to use that to determine if we have an even or odd length. And then we're going to go ahead and actually sort the values. Okay, so this command here simply sorts those values. Okay, and now we do a little bit of logic here. So if the length, okay, is even, so this is basically saying that there's no remainder, we'll take the mid value, okay, which is the length of the values, okay, then we take the floor, okay, which discards the decimal part, and that'll kind of give us an idea of where that center is for an even set of numbers. Okay, the median will simply be the average of the middle two numbers, and that's what this part of the code will do right here. And the divide by 2, Okay, you're taking the average of two numbers, and that's how you would calculate it. Otherwise, if it's not an even length, okay, it's going to be odd, and the middle value is simply going to be the length of those values divided by 2. Okay, take the floor again of that value. The median is simply going to be in the middle of that and return the median. So let's go ahead and try to run this function. So let's go ahead and copy it. Put it back over here. See if it is in there. Median value. And it is a class function, so let's go ahead and actually use this on our data set from above. 54.5. So you can see that the median is much different than the average. And again, a little bit of statistics coaching here. You know, the median is more resistant to outliers than the average is. And if you look at our list that we actually put in there, you know, these first few values look, you know, this first part of the string of numbers looks pretty darn good. But this last part right here is a gigantic outlier. So that influences the mean, you know, pretty heavily, whereas the median is not influenced as much. Okay. Okay, we're going to do one last function. One of the things that's of interest is looking at what's called the coefficient of skewness. So you can take the mean and the median and divide it by the standard deviation of the numbers and get something called the coefficient of skewness. So it's kind of a way of kind of seeing how influential some of the data points are. And you know, if you have a perfectly, you know, balanced data set, it's symmetric, you know, the mean and the median will be the same number, so the coefficient of skewness will be 0. But we want to see how far off that is, especially in the presence of big outliers. You can read more about that. Most stat books have something about that. So we're going to create a function called skewness. And again, we're going to input some kind of values. Now here's a change. So here we're using this import function in Python, importing numpy, okay, as np. So numpy is actually a library, kind of a numerical library out there with a bunch of really cool functions for dealing with math type stuff. Okay, so we're going to actually import this in, this library, and then give it this alias here. And one of the things this coefficient skewness needs is the actual standard deviation. So we could do it manually. You know, we could say, well, we're going to, you know, calculate the average and then subtract off the data points, then square them, and then divide by n, and, you know, take the square root, blah, blah, blah. But this library right here already provides a function to do that. So here's an example of actually calling a function inside of another function. Okay, so this is helps us quite a bit. Okay, it really simplifies our code quite a bit. And then we'll still go ahead and calculate the coefficient of skewness here. And take the mean value of the values minus the median value, and then kind of scale it by the standard deviation. And that's the definition of the coefficient of skewness. And notice that we've actually called also in the functions that we created above. So this mean value, okay, is the function we developed up here, and the median value is the function that we've developed here. So one of the key points is, you know, if you're going to do that, you got to make sure that these functions are defined somewhere in the program before you get to this point. So this is very, very important to keep in mind as well. And then we're simply going to return that coefficient. So let's go ahead and copy this. You know, also another thing I need to mention is, you know, for all of these, you should also probably be putting in some kind of, you know, verbiage about what they are, because, you know, you come back later and you always forget about, you know, what it was about or what you were doing. So again, go ahead and, you know, try to add some kind of commentary in there if you can. And then we'll go ahead and copy this over here. And make sure that's the function. Class function. And, you know, numpy also does the mean and the median as well. So we didn't have to write our own functions up here if we didn't want to. So let's go ahead and try it out here on our data values. Oops, got to type it correctly. And I still can't type it. No forgiveness in the computer world here. And it gives us the coefficient of skewness of 0.33. And again, you can look that up in a stat book and kind of get a feel for what that means. Anyway, that's kind of the basics of functions. A lot of ways to look at functions, a lot of material out there to understand them better, a lot of great books on Python and developing functions. But again, this is just kind of a basic introduction, and I hope it helps you along your way and develop some great functions. Thanks, and we'll talk to you again.